Hello hams and radio experimenters, Tinkerham here. In a previous video I showed you how to generate a low-level RF signal in the VHF and UHF ham bands using a low-cost scanning radio. In this video I'm going to show you a couple of simple mods that you can do to increase the usefulness of your scanner even more. The first mod is to the receiver side. This is referenced in articles about the poor man's deviation meter. So yes, you can measure FM deviation on a pure sine wave using Bessel-Null methods, but it's really not practical to do with live audio. Through this simple but useful modification, you can tap the DC level of the FM discriminator, bring that out through a jack, and visualize that with an oscilloscope or a meter. I've used a 1/8 inch headphone jack here, as it's the same as the sound card in my computer. The discriminator circuit is what converts the FM signal to audio. Ordinarily, this audio goes through a de-emphasis filter to make it sound better before going through the squelch and volume control circuits. But bypassing this de-emphasis filter and direct coupling to the discriminator provides you with a signal that's more useful in a number of ways. First, it provides the DC voltage value of the frequency deviation or error. If the frequency of the received signal is centered in the receiver passband, the discriminator will produce a DC voltage between 1.8 to 7 volts, depending on the scanner. If the received frequency is shifted high or low from where you're expecting it or where it's supposed to be, this voltage will be higher or lower relative to the error in frequency of the transmitting source or of the receiver being off frequency. I can demonstrate this effect with my 847 transmitting and shift a frequency while transmitting into a dummy load. As I go down, you can observe a change in the meter and return back to the center frequency, and then increase frequency slightly, notice the meter, and return back to center. So that can help you identify if your transmitter is a little bit off frequency. If you need to adjust it, you can do this remotely, or you can use a frequency counter. Kind of a useful side effect. Secondly, it can also show your transmitter's subaudible tone, or PL or CTCS, whatever you wish to call it, and allow you to measure the frequency and deviation of the tone. Do you have a radio that has a tone that doesn't always decode into the repeater, or people that tell you your audio has a buzz or a hum? With this trick you can interface to the discriminator, use a frequency counter or an oscilloscope, measure what your deviation is, and measure the frequency of it. Thirdly, you can detect and measure the frequency deviation of your FM transmitter, make basically a deviation meter, or interface it to an oscilloscope or sound card oscilloscope in your PC to monitor your transmitted FM audio. Heathkit made a unitasker device for this, their own special deviation meter. It did the job pretty well. Problem is it's manually tuned, and it's really only good for one frequency at a time and does tend to drift. And even after the mods you perform on your scanner, it can still be used as a scanner. You can monitor multiple repeaters. You can use it as a signal generator. You could monitor your deviation, watch your own signal on it, or just listen to other people chat. That's the advantage of this. Test 1, 2, 3, 4. Testing 1, 2, 3, 4, 5. 5, 4, 3, 2, 1 test. The next modification I'm going to show you is how to get the RF out in a more controlled manner. If you notice the highlighted section on the block diagram, it shows a 10K variable potentiometer, a small jack, and a 0.1 microfarad isolation capacitor. If you look where I'm pointing in the scanner here, you can see where I tapped into the scanner added a small wire, the potentiometer, 10K audio taper volume control, and a small SMA jack. The capacitor is in there for DC isolation, so you're not going to be bringing any DC out to the unit you're testing or getting DC back into the scanner accidentally. I just drilled a hole in the side to install the connectors. Now, if you also notice, there's a black wire in there in the bottom section of the block diagram that shows a stereo jack and a couple of 2.2K resistors and another isolation cap. This is to bring audio into the scanner that allows you to modulate the voltage controlled oscillator in the scanner, that you could actually generate a tone or multiple tones with the scanner. Now, the reason why I used a stereo jack is because my sound card in the computer generates a dual audio tone. This is an example that I've done with the Zellscope signal generator of generating a subaudible tone to CTCSS 131.8 on channel 2. And then I generate a frequency that's 10 times that on channel 1, and then it's passively mixed by the resistors on the audio connector inside the scanner. Then it modulates the scanner voltage controlled oscillator, and in this case it's being picked up by the desktop scanner. The desktop scanner is generated, it's being picked up by the handheld scanner. And in this demonstration here, I am turning off the lower frequency, the subaudible tone, and just showing the 1.3 kilohertz tone by itself. This is being generated by the scanner at this point. Now, this is the old way of generating audio, using the +5, -5 kilohertz stepped frequency and then the open squelch in between. This is not very pretty on the screen. And change modes here, see if I can get it a little more tight in the generation here, and hit scan, and no, still not right. Hang on for a sec. Let me reconfigure this. That's it. This should be a square wave, but due to the DC blocking capacitor and the frequency roll-off and the mic input on my sound card, it doesn't look real pretty. But it gets the job done. So good luck with your experimenting. This is Tinkerham saying 73 and signing off.